Assalamualaikum and good day everyone. So today we are going into the last part of 5.1. Okay, so on real gases. So let's have a look at the learning outcome for this part. So first one, kita akan tengok how to explain qualitatively the ideal and also non-ideal behaviors of gas in terms of intermolecular forces and also molecular volume dia. So yang ni nanti kita akan guna a new equation yang kita ambil daripada PV equals to nRT sebenarnya lah. Okay, and then kita akan tengok the condition at which real gases approach the ideal behavior. Okay, so first kita tengok dahulu pasal real gases. So sebenarnya what is real gases? Real gases are the gases that deviate from the ideal gas law. Bermaksud awal-awal kita belajar topik ni dahulu, yang 5.1 ni, we learn about the 4 basic assumption of ideal gas kan. Ada 4 basic assumption tu, tapi untuk real gases basically dia tak follow the 4 assumption lah. Specifically kita akan tengok 2 daripada assumption tu sebenarnya. Okay, so real gas is also known as a non-ideal gas. So real gases are non-ideal gas whose molecule occupy space and have interaction. Okay, so ingat balik tak, antara 2 daripada basic assumption yang kita belajar tu, kita ada belajar yang pasal intermolecular forces is negligible between the gas particle, and also the molecular volume of the gas particle is also negligible. Kita ignore juga kan. Tapi untuk real gases kita akan the idea of the real gases, dia punya behavior adalah the molecule they occupy space. Bermaksud we cannot ignore the volume of the gas particle, and also it have interaction, meaning we cannot ignore the intermolecular forces between the gas particles then. Okay, so they do not behave according to the assumptions of the kinetic molecular theory. Ini yang 4 basic assumption tu lah. Okay, so the deviation of real gas from the ideal gas behavior can be shown from plotting PVRT against pressure. So yang graph yang kita akan tengok sini adalah lebih kepada yang at constant temperature. So our focus is more on pressure lah dekat sini. Okay, so as you can see, as the pressure increases, so kalau kita ada 1 mole of any gas, kalau dia ideal, kita akan nampak dia constant dekat sini sepatutnya. Okay, tapi bila kita tengok gas yang sebenar, behavior dia macam mana, dia deviates from this particular line here. As you can see, as the pressure increases, at some point dia macam behave ideally. Okay, sebab semua kamu boleh nampak point ni yang dia cross dekat bahagian ideal gas kan. But as the pressure increases, dia deviate further from the ideal gas punya behavior. Okay, yang ni kita boleh tengok ini. Dia kata observe how the curve of the gases deviate from the horizontal line that representing the ideal gas. Okay, this is the case bila temperature constant. So what about kalau dekat temperature berubah pula, so adakah akan deviate juga kita punya behavior of gas tu sebenarnya? Okay, yang ni pula adalah different temperature. So as you can see, yang ni, okay, so at a certain temperature the gas will behave ideally. Okay, so ini ideal gas punya line. Okay, tapi as you can see here, kita boleh nampak ada temperature 273, 600 and 100K. So we can see that even like at the different temperature pun the gas actually deviates further from the ideal gas. Tapi we can see that as the temperature increases, actually dia semakin mendekati ideal gas punya behavior, and as the temperature lowers down, dia makin jauh daripada ideal gas behavior. Okay, so sama juga dekat sini tadi, kalau kita tengok balik yang graph yang berbeza pressure ni. So kalau kita tengok, as the pressure increases, it deviates further from the ideal gas behavior. Tapi as the pressure lowers down, dia makin mendekati ideal gas behavior. Okay, so now kita dah boleh nampak dah sebenarnya condition yang dekat mana yang gas akan behave ideally, and dekat mana yang gas akan behave as a real gas ataupun non-ideally. Okay, so kalau kita tengok dahulu untuk ni, kita try fahamkan dahulu macam mana sebenarnya, apa penyebab deviation of the behavior of the ideal gas sebenarnya untuk certain gas ni. So due to the 2 assumptions of the kinetic theory of gases, whereby the first one, kita dah belajar dah yang kalau gas particle ni is a very tiny particles, right? To the point that we just ignore the volume of the gas particle. Okay, so negligible volume. So kita just ambil the volume of the container aja sebagai volume of the system, the whole system itself. Okay, and then Yang kedua pula, there are no intermolecular forces between the gas particle, so kita ignore the IMF between the gas particle. Okay, but then real gas, dia deviates from the ideal gas behavior when it is at a high pressure and also low temperature. So what's the reason for this? So let's have a look dekat the first one dahulu. So dekat high pressure, the gas is compressed. So bila gas compress high pressure, so what happened to the volume is the volume of the container akan decrease dan. So bila volume of the container decrease, the distance between the gas particle becomes closer to one another. So bila dia lagi dekat with one another, waktu ni kita dah tak boleh dah nak ignore apa? Kita dah tak boleh nak ignore the intermolecular forces between the gas particle, because the possibility untuk diorang interact with one another adalah lagi tinggi. So waktu tu dah tak boleh ignore dah sebenarnya intermolecular forces. The intermolecular forces between the gas particle become more significant. So it deviates from the ideal gas behavior, because sepatutnya kita boleh ignore sebenarnya kan, kalau ideal gas kita ignore IMF. Tapi as the volume becomes smaller, so now the particles are getting closer to one another, so we cannot ignore the IMF. So that happens when condition dia adalah dekat high pressure. Okay, so what about low temperature pula? So low temperature pula, meaning kinetic energy of the gas particle is lower, so the movement of the gas particle become slower then. Okay, so bila dia become slower, bermaksud dia orang akan lagi dekat with one another then. Okay, so as you can see here, okay, ini adalah dekat low temperature, so movement of kita punya gas particle dalam ni dia become slower, so ada possibility untuk dia orang jadi lagi dekat with one another lah. Okay, so the intermolecular forces become significant. Sebab bila dia slower tu, volume dia pun jadi lagi kecil kan. So dia memang akan macam akan interact with one another. So here sekali lagi kita tengok, kita tak boleh nak ignore dah intermolecular forces. So intermolecular forces between the gas particle become more significant at a high pressure and also low temperature. Okay, but then the gas behave ideally when it is at a low pressure and also high temperature. Kenapa? Apa pula yang berlaku? So of course dia terbalik kepada semua yang kita dah tengok tadi, because at low pressure bermaksud volume akan increase dan. Okay, so bila volume increase bermaksud the distance between the gas particles now are getting further apart from one another. So bila further apart from one another, meaning will they interact more ataupun they will interact less? So of course they will interact less with one another then. So since less interaction between the gas particle, so dekat situ kita boleh ignore intermolecular forces dan. Okay, so since kita boleh ignore intermolecular forces, bermaksud the gas behave more ideally dan. Okay, and then what happened dekat high temperature pula? Bila dekat high temperature, the average kinetic energy of the gas particle increases. Maksud dia akan bergerak dengan lagi cepat. Okay, bila dia lagi cepat juga, at the same time dia jadi lagi further apart from one another. So boleh nampak dalam ni lah, compared to yang gambar yang sebelum ni yang dekat low temperature tu, boleh tengok balik, yang tu distance dia lagi dekat bila dia move slower. Tapi bila dia move faster, the distance become further apart. Bila distance become further apart, meaning we can ignore intermolecular forces between the gas particle, therefore the gas is said to be behave ideally then. Okay, so real gases, okay, so kena ingat kalau real gases ni dia akan deviates from the ideal gas behavior when it is at a high pressure and also low temperature. Meanwhile ideal gas pula it behaves as an ideal gas at a low pressure and also high temperature. The reason is because IMF untuk real gases more significant. Okay, so bila more significant, apa ni? Significant, tengok spell betul-betul, okay? IMF more significant untuk real gases, therefore dia dah akan deviates from the ideal gas behavior. Tapi kalau yang ideal gas, kalau dekat low pressure, high temperature, that is because IMF is not significant. Okay, so meaning kat sini kita boleh ignore the IMF between the gas particle. So dekat low pressure, high temperature tu sebab distance dia lagi further apart, kita ignore the IMF, so it behaves ideally. Tapi kalau dekat high pressure, low temperature, the distance between the gas particle become closer to one another, so the IMF is more significant, so dia akan deviates from the ideal gas behavior then. Okay, okay, jadi disebabkan real gas dia behave lain compared to kita punya ideal gas. Meaning, kalau kita nak kira sebenarnya pressure of a real gas, we cannot use PV equals to nRT as it is. Meaning, we need to do some correction ataupun some adjustment towards the PV equals to nRT punya equation, ideal gas equation tu. So, here comes the part yang kita diintroduce dengan Van der Waals equation. So Van der Waals equation ni diintroduce oleh saintis Van der Waals ni sebenarnya lah. Okay, so kita kena adjust sikit kita punya PV equals to nRT. So PV equals to nRT tu, since the real gas does not exhibit ideal gas behavior at high pressure and also at a low temperature. So apa yang kita nak kena consider dekat sini ada dua. Satu adalah volume. Okay, sebab dekat high pressure, low temperature, we cannot ignore the volume of the gas particle already. Okay, it become more significant. At the same time, the attraction forces between the gas particle pun become more significant juga kat sini, meaning we cannot ignore on that as well. Okay, so dia akan affect pressure dengan volume of the system nanti. Okay, so first kita tengok in terms of volume dahululah. So, in the ideal gas equation, PV equals to nRT, the value V represents the volume of the container. We usually ambil je the volume of the container, kita letak dekat dalam parameter V tu kan. Okay, tapi sebenarnya bila kita tengok yang sebenar dalam sistem tu, okay, so kita ada satu sistem. So dia ada size dia sendiri, volume of container tu sendiri, and then dalam tu ada gas particle. The moment ada something dalam gas particle tu, so the area yang the gas particle boleh cover is actually less than the volume of the container itself, kan? Okay, sebab the moment kita masukkan something dalam tu, so ruang yang tinggal is actually lagi sikit daripada ruang sebenar kalau container tu kosong. Okay, so the volume available for the gas particle to move about in a container is always less than the observed volume because the gas particle occupied a sizable portion of the container. Jadi kita kena adjust sikit dan the volume dan. Okay, so the space occupied by the gas particle causes the value of PV RT to deviate from the predicted value. So the volume occupied the gas particle must be subtracted from the total volume dan. So kita dapat yang effective volume ni. Effective volume ni adalah volume for the gas particle to move around. The gas particles to move around. Okay, jadi apa yang kita kena buat adalah kita ambil volume container tu and then kita tolak dengan volume sebenar gas particle tersebut. So macam mana kita nak kira volume of the gas particle? So kita anggap V occupied by the gas particles equals to NP, where N adalah number of mole and V pula adalah constant representing the volume occupied by the gas particle. So kena ingatlah V tu adalah constant. Okay, constant yang melibatkan volume of gas particle. Okay, jadi kalau kita substitute masuk dalam formula yang ni, so basically V effective equals to V container minus NP. So kita KIV dahulu equation yang ni kelas, nanti kita substitute masuk dalam ideal gas equation. Okay, so next one kita tengok in terms of attractive forces pula. So the pressure of the gas is caused by the bombardment of gas particles on the wall of container. Okay, however, bila ada attraction forces between the gas particle yang kita tak boleh nak ignore dah, so apa yang berlaku? The movement of the gas particle become slower. So bila movement of gas particle become slower, sebab mula maybe dia macam langgar macam biasa kan, tapi bila ada attraction forces, kalau dia orang nak berpisah, so since ada attraction forces, so dia akan menyebabkan movement of the particles jadi slow dan. So bila dia lagi slow, so bila dia langgar the wall of container pun, it doesn't give that like impact yang tinggi dekat situ. So menyebabkan pressure real gas is actually lower daripada ideal gas punya pressure sebenarnya. Okay, so it give less impact to the wall, therefore the pressure exerted by the real gas reduce, causing the PVRT to deviate from the predicted value juga. So basically pressure of real gas is lower than the ideal gas. Okay, kiranya kalau kamu guna je PV equals to nRT untuk cari pressure, okay, and then bila kamu kira sebenarnya pressure sebenar real gas tu, it should be lower than P yang kamu kira initially tu tadi kalau guna ideal gas tu. Okay, jadi macam mana kita nak buat adjustment dekat sini? So kita akan masukkan some coefficient dekat sini. Okay, so kalau tadi ada B adalah constant yang melibatkan the volume of the molecule. Okay, sekarang kita ada A dekat sini, kelas A. So what is A? A adalah constant describing the strength of the attraction forces between the molecule. So masih lagi N dekat sini adalah number of mole. Okay, V kat sini volume of container lah sebenarnya. Okay, volume of container biasa. Okay, so therefore P ideal is equals to P real plus H squared A over V squared. Okay, jadi now kita nak substitute masuk dua equation yang warna kotak kuning ni ke dalam PV equals to nRT. So by substituting this equation here, this formula here into equation PV equals nRT, so now we have this particular equation here. Okay, so number of moles, and then A constant describing the strength of attraction between the gas particle, and also B constant representing the volume occupied by the gas particle. Okay, right, so luckily there's no calculation involving the van der Waals equation. Tapi apa yang penting untuk van der Waals equation ni adalah kamu kena tahu macam mana value A dengan B tu boleh affect the pressure of the real gas. Okay, so keep in your mind that A dengan B ni, A and B punya coefficient ni, dia adalah generally, secara generalnya dia akan increase as the molecular size of the gas particle increase. Okay, and apa pula impact molecular size towards intermolecular forces ataupun van der Waals forces specifically. So kalau size of the molecule lagi besar, IMF pun akan jadi lagi kuat dan okay, so bila A and B punya value lagi tinggi due to the molecular size, okay, this shows that the intermolecular forces, the strength of intermolecular forces between the gas particles is actually stronger. So bila stronger bermaksud the P, pressure of the real gas akan lowers down then. So bila dia lowers down, meaning this one deviates more from ideal gas behavior. Okay, however, kalau value A dengan B kita kecil, bermaksud size molecule tu kecil sebenarnya. So intermolecular forces between the gas particle is also weaker. So the pressure of the gas dia akan jadi tinggi sikit. So bila dia tinggi sikit tu, most probably dia akan mendekati the ideal gas behavior. So you have to know apa peranan A dengan B dalam van der Waals equation ni sebenarnya. Okay, so just kena tahulah kalau A and B lagi tinggi, sebenarnya sebab apa? Sebab molecular size. So kalau molecular size tu besar, bermaksud IMF kuat. Tapi kalau molecular size tu rendah, bermaksud IMF rendah. Okay, so yang mana yang akan menunjukkan the gas actually behave more ideally ataupun the gas behave less ideal dan okay, so ada beberapa benda kena ingat lah kelas. First, kena ingat what kind of condition yang gas tu akan behave ideally. So it has to be dekat a lower pressure and also high temperature kan, okay, because dekat situ IMF is less significant. However, kalau gas behave as a real gas, bermaksud dia deviates from the ideal gas behavior only on condition yang pressure dia lagi tinggi and also low temperature. Kenapa? Sebab waktu tu distance between the gas particle is closer to one another, so the IMF is more significant. So bila IMF is more significant, bermaksud dia akan deviates further from the ideal gas behavior. Okay, and then satu lagi, yang tu pasal condition, dan satu lagi macam mana kita nak relatekan dengan the van der Waals equation. So kena tahu macam mana A dengan B tu boleh affect the pressure of the real gas. Okay, so basically lagi besar value A and B, that has something to do with the molecular size, sebab molecular size lagi besar. Ataupun kalau lagi kecil value A and B tu, of course it shows that the molecular size of the particle adalah lagi kecil. So macam mana pula size to affect the IMF, and then macam mana the effect of pressure gas, yang tu semua tu pressure of the gas, yang tu semua nak kena take note on that salah. Okay, but no calculation involved for this part. Itu sahaja. Alright, so see you guys again. Bye.